Welcome back to Infinity Beyond, where tonight we take the Snowball Earth hypothesis and launch it into the cosmos. We've explored how Earth may have once been completely frozen, a silent world wrapped in ice, with life surviving beneath in dark, hidden oceans. But what if Earth wasn't the only planet to experience such a fate? What if frozen worlds, seemingly dead, icy planets, are actually alive beneath the surface? It's not just science fiction. It's a hypothesis with growing support. Let's begin close to home, with Europa, one of Jupiter's moons. Europa is roughly the size of Earth's moon, but unlike our cratered satellite, it's covered in smooth, bright ice. Beneath that frozen crust, scientists believe there lies a liquid water ocean, kept warm not by sunlight, but by tidal heating, gravitational friction caused by Jupiter's immense pull. Here, in this subterranean sea, conditions may resemble those of early Earth during its snowball phases. Hydrothermal vents on Europa's ocean floor could be spewing minerals and heat, just as they did on our planet. And where there's warmth, water, and chemistry, there could be life. Not far behind is Enceladus, a tiny moon orbiting Saturn. Though smaller, Enceladus surprised the world in 2005 when the Cassini spacecraft spotted geysers erupting from its south pole, plumes of water vapor, organics, and salts shooting into space. These weren't just signs of water, but clues to a global ocean beneath its icy crust. The fact that such moons may host internal oceans raises a fascinating question. Could snowball planets or moons, completely frozen on the outside, be teeming with life on the inside? And could the same principle apply to exoplanets, worlds orbiting other stars? Take a moment to imagine a planet like Earth, orbiting a red dwarf star, a common type of star in the galaxy. Red dwarfs are cooler and dimmer than our Sun. Planets in their habitable zones receive much less light. If such a planet lacks a strong atmosphere or internal heating, it might freeze over entirely. At first glance, that seems like the end of the story. A dead, frozen planet. But Earth teaches us otherwise. Remember, during Snowball Earth, life persisted. It didn't need sunshine. It didn't need land or even air. It found safety in the darkness, clinging to vents, floating in brine pockets, hiding beneath the ice. If life could endure here, then why not out there? This shifts the habitable zone concept in astronomy. Traditionally, scientists focused on finding exoplanets with Earth-like temperatures and atmospheres, a so-called Goldilocks zone. But now some are proposing a subsurface habitability model, where planets outside the traditional zone might still host life below their icy surfaces. What's more, ice can act as a shield, protecting internal oceans from cosmic radiation, solar flares, and meteoric impacts. In some ways, a snowball world might be more stable for microbial life than a volatile surface environment. Of course, life in such worlds would be alien, perhaps chemosynthetic, slow-growing, or entirely unfamiliar. But that doesn't mean it's impossible. In fact, the most common types of life on Earth are microbial extremophiles, bacteria and archaea that thrive in boiling vents, toxic acid pools, and deep Antarctic lakes buried beneath glaciers. These organisms are not the exception. They are the foundation of biology. So if alien life does exist, it might not be building cities or sending radio signals. It might be floating beneath a kilometer of ice, feeding on chemical gradients, glowing faintly in the dark. And there's more. Scientists have proposed that icy exoplanets might occasionally thaw due to changes in orbital eccentricity, nearby stellar flares, or internal geothermal cycles. These periodic warmings could trigger evolutionary bursts, like Earth's post-snowball bloom. It's possible that life, even in cold places, comes in waves, retreating during deep freeze, thriving during rare thaws. This paints a much broader picture of what it means for a world to be habitable. Snowball Earth, in all its frozen silence, may have been one of the most important stages in our planet's biological evolution. Without it, perhaps life would have remained simple, stagnant, or even perished. Instead, it adapted, endured, and evolved. That same template might be repeating over and over again across the galaxy. So when we look at icy exoplanets with telescopes, we should not dismiss them. We should imagine what's beneath, what might be swimming in oceans we cannot yet see. In upcoming missions, like Europa Clipper and JUICE, humanity will get closer than ever to investigating these frozen frontiers. Subsurface probes, radar mapping, and sample return missions might one day confirm what we've long suspected, that life doesn't always need warmth, light, or even surface. Sometimes, all it needs is a place to hide. As we end this segment of Infinity Beyond, let's reflect on this. The universe may be cold, it may be quiet, but that doesn't mean it's lifeless. It just means life knows how to survive in the shadows. In the next episode, we'll return to Earth to examine how Snowball Earth has reshaped modern climate science and what lessons it teaches us about our planet's present and precarious future. Until then, keep wondering, keep watching the stars, and keep exploring with Infinity Beyond.